Okay, our swinging chair question. We've got a chair swinging by two ropes from two trees, I think it is. So it's held by rope. Clearly the tension is holding it up, and we're told that that's 60 degrees, and that's tension 1. We've got another rope acting over there. Clearly the tension is going up that way, T2, and we are told that's 30 degrees. And the chair, we've got a weight of 8 kilograms. Rather than multiplying that to get our force by acceleration 9.8, I'm just going to put 8g so that we don't get any decimals. Clearly the chair is not swinging, so we want to get our resultant vector, add all those force vectors together, and we're going to get a 0 resultant. Let's start with the blue. So we're going to get our vector in there. Now, because we want to use our rule, A vector is the magnitude of A cos theta I plus sine theta j. We need this angle. We don't want to use our 60, we want our angle 2, our positive x-axis, so that's 120 degrees, I believe. So when we multiply it, our magnitude of A is our tension, which is unknown, so we just have to leave that as tension 1, cos 120. So that's our first force vector. Now we're going to add our green. Just so I don't run out of room, I'm going to start on the row beneath. So we need our angle to our positive x-axis, 30 degrees. And we're going to go, we don't know what T2 is, so that's unknown. And it's definitely cos theta sine theta. And our third vector acting is our weight vector. Clearly there's 0 horizontal and the 8g is going down, and our resultant vector is 0. That's all well and good. We want to simplify these a little bit. Ideally you will know what cos 120 is. You'll see that we're dealing with 30s and 60s, so we're dealing with exact values here. So please don't just whack in there your decimal answers. Cos 120 is negative a half, and that sort of makes sense because it's out that way, isn't it? Negative a half, T1, and sine 120 is a root 3 on 2. And our green one, cos 30, root 3 on 2, and sine 30 is a half, and then our black one is plus 0. Now out here the 0 vector is actually a vector 0, 0, 0i plus 0j. So what we can do is we are going to correlate our I components. So we're going to put all of these i's together. So we're going to get negative T1 on 2 plus root 3 T2 on 2 plus 0 equals 0. And when we correlate our j components, we're going to get root 3 T1 on 2 plus T2 on 2 minus 8g equals 0. Now, once we've got here, all of our vector work has done its job, because as you can see, we've got two equations and two unknowns, T1 and T2. So that's equation 1 and equation 2. So I'm going to get equation 1 here. I'm going to multiply by 2 and get the T1 to the other side. So I'm going to get T1 equals root 3 T2. I'll label that equation 3. Now I'm going to get this 8g. Oh look, it doesn't really matter. I could get 8g to the other side, it doesn't really matter. But what I might do is just get rid of this 2. So I'm going to go root 3 T1 plus T2 equals 16g. I'm going to use substitution, absolutely set up for substitution because T1 equals root 3 T2. So see this T1? Root 3 multiplied by T1, which is root 3 T2 plus T2 equals 16g. The two root 3's. And then we've got 4t2 and t2 equals 4g. So once you get it to those simultaneous equations, it just works out. t2 is 4g, so we can come up to find out what t1 is. So t1 will equal 4 root 3 g, and hopefully that's the correct answer. Okay, awesome, job done.